So in this section, we're going to be talking about exponential growth and decay in some real life situations. So we've looked at what the graphs look like, and now we're going to look at kind of an equation that's similar to what we looked at in the last section, but in a real life situation when we have some percentage rates. So in this in these examples, we're going to use this equation, and it is the A is going to stand for our initial amount. The R is going to stand for our rate. Now, this rate has to be changed, the percent rate has to be changed into a decimal. That's really, really important. So if we were given, say, a 2% rate, we would switch that and move our decimal over 2 places to the left, giving us 0.02. If we had 38%, we would move our decimal over 2 places, giving us 0.38. So make sure every single time you are switching that R to a decimal in order to use it in your equation. And then our X is normally how much time they're talking about. So let's look at some examples. One more thing. If you're looking at these equations, you'll see that plus or minus. You're not going to use both. It's going to be a plus or a minus, one or the other. So how you determine that is if it tells you your situation is growing, it's increasing, it's getting bigger, something of that sort, that is when you are going to use that plus. You have a growth situation. If your situation says it's declining, decreasing, decaying, that's how you know you're going to use that subtraction because your equation's going down. So let's look at some examples and see what we can find. The first example we have, it says, suppose a city population of 100,000 has been growing at a rate of 8% per year. If this rate continues, find the population after 24 years. So the first thing I like to do is just focus on how to find the equation for this. So our initial amount was that 100,000 people, and our percentage rate was 8%. Now we need to switch that to a decimal. So I'm going to take my decimal and move it over 2 places. So I have 0.08. So plugging that into my equation, I had an initial amount of 100,000, and I saw that it said that we were growing. So my situation is getting bigger. So I'm going to use the plus in this, and my R was 0.08 to the X power. To simplify this a little bit, I would add these two together. 1 plus 0.08, I can add together, giving me 1.08 to the X power. So here is my equation. Now, they asked me to find something out using this equation. What's going to happen in 24 years? So I'm going to plug in 24 to my X in my equation, because normally that X is always going to be looking at time. And we're going to plug that into our calculators. You can plug it in directly into your calculator, 100,000, 1.08 to the 24th power. And it looks like we have 634,100, and 18.0737. Now, in this situation, we were talking about people. I don't want 0.0737 of a person, so I'm going to round to the whole number. After that whole number is a 0, which means I'm going to keep that 8 and 8. I don't want to round it up. So my estimated population is this many people. I would highly recommend you label your answers. Super important. Okay, let's try another example. If you want to pause the video now, the next one's very similar. You can try it on your own first and see how you do. Okay, so this one we have a population of 900,000. So that's our initial amount we're looking at. And we are growing at a rate of 7%. So that 7%, I'm going to switch to a decimal, giving me 0.07. So plugging all of that into my equation, I got that 900,000. 1, and again, my population was growing, so I'm going to use that plus. 0.07 to the x power. Now, again, I can always simplify this by adding my two things in the parentheses together, which gives me 1.07 to the x power. So here's my equation that works for any sort of time. I personally want to know what's happening in 13 years. So in that equation, I'm going to plug in 13 into my x and see what I get. So please take this to your calculator and see what you get in 13 years. And it looks like I have 2,168,860.5 people. Now, again, we're talking about people, so I want to round to the whole number. I have 0.5. So it looks like I need to round that 0 up to become a 1. So this is going to become a 1, and we're talking about people again, so I'm going to label my answer. And this is about how many people I will have in 13 years. Okay, next example, I have the number of employees in a company is decreasing. So now we're going down each year by 4%. The company is currently at 770 employees. Find the number of employees in 7 years. So it looks like our initial amount was 770 employees. And our percent was 4%, but we need to switch that to a decimal, giving me 0.04. So our equation is y equals that 770 and 1. I need to use a minus because we just said we were decreasing by that percentage rate of 0.04 to the x power. Now, if I combine my like terms inside that parentheses, I have 1 minus 0.04. If I plug that in my calculator, I get 0.96. So here's my equation that works for any situation. But in ours, we were asked what happens in 7 years. So let's plug that in to our equation and see what happens in 7 years. Plug this into your calculator and we get 578.61. And it looks like, again, we're talking about people, employees. I can't have 0.6 of an employee. Since it was 0.6, it looks like I need to round this 8 up to become a 9. So I'm going to make it 579 employees. If you want to pause right now and try the next example on your own, do so please. Okay, looking at this example, it looks like we have another company that is decreasing by 7% each year and is currently holding 500 employees. We need to find the number of employees after 15 years. So our initial amount is 500 employees that we're starting with, and our rate is 7%. So if I move that decimal over, I have 0.07. Again, we're decreasing, so I'm going to have to use a minus when I write my equation. So this is going to be y equals 500 1 minus 0.07 to the x power. If I combine my like terms in the parentheses, 1 minus 0.07 would give me 0.93 to the x power. So here I have my equation that's going to work for anything, but I want to know what's happening in 15 years. So I'm going to plug in that 15 into my x. So, 500 times 0.93 to the 15th power. If you plug that into your calculator, we get 168.35. Again, we want a whole number if we're talking about people. So I have an 8.3. It looks like that 8 is going to stay an 8. So we have 168 employees about. So if you notice, the last 4 examples that we did were all talking about something that was happening per year, each year. These next examples that we go into are not going to be the same. They're going to give me a number of times that these equations or these problems happen in a year, and they're going to use the word compounding. So let's look at the next example. Which of investment results in a greater total? So let's look at each one of these. Now this equation, they give us a different equation this time, and the only thing that's really different is these n's. That exponent of t is still going to stand for time, but we also have n in the exponent, and our r is divided by n. What these n's mean is the number of times, they happen per year. So looking at these examples, we're going to try to figure out what that means. So it says investment A has $4,000 invested for 5 years, compounded semi-annually at 6%. So let's start to fill out our equation. We're talking about investment A, and it starts off with $4,000, and it says 1 plus, and our rate was 6%. We got to move that decimal over 2 to give us 0.06. Now, we need to figure out what that's divided by. It's a number of times per year. Well, it said that this was compounding semi-annually. Semi-annually means 2 times per year. So we are going to divide this by 2, and part of our exponent is going to be to the second. We also need to figure out how long are we doing this. And it said that we're doing this for 5 years. So when you go to plug this into your calculator, I want you to be very, very careful because we have a fraction. That 0.06 was divided by 2. So in order to make that a fraction, you're going to need an extra set of parentheses. Notice right here we have a closed parentheses and another closed parentheses. Make sure you're typing that into your calculator. Okay, when you type that in exactly how it looks on your paper, we should get 5,375.6. And then remember, we're talking about money in this situation. So in money, I always have 2 numbers after my decimal. So that's what I want mine to look like on my paper as well. So I had 0.665 in my calculator. Since it was a 6.5, I'm going to round that 6 up to a 7. So we have $5,375.67. Okay, let's compare this to investment B. Investment B says $6,000 invested for 3 years, compounded quarterly at 2.7%. So our initial amount was $6,000. And our rate was 2.7, so I'm going to move that decimal over to make it 0.027. And it said that we were compounding quarterly. If you think about quarters, that's 4. So 4 times per year is what quarterly means. So we're going to divide by 4, and part of our exponent is going to be 4 as well. It also said that we were doing this for 3 years. So after 3 years, let's plug this into our calculator and see what we get. Remember, we have a fraction, so you need to type an extra set of parentheses into your calculator. So typing all that in, we should get, $6,504, and it looks like it's a 454. Since it was a 4 after that, I'm going to round it and leave it as a 5 because we're talking about money. I only want 2 decimals, so 45 cents. Okay, so we need to compare these. Now the question says, which of investment is a greater total? Looking at just these 2 totals, it would appear that B is the better investment because we ended up with more in the end. But there's a couple other parts to this that we need to take into consideration. In investment B, we started with $6,000 and ended with $6,500. In investment A, we started with $4,000 and ended with $4,375. So our change was a lot greater in investment A. The other thing we need to take into consideration is how long these two are happening. It's really hard to compare something that happened for 3 years versus something that happened for 5 years. So the best thing that I could say to do is let's figure out what investment B would be at after 5 years. So let's calculate this one again and see what is this one going to be like after 5 years and see if that makes a difference. So 0.027 divided by 4 still, but our time is going to change to 5. So let's plug that into our calculator and see what does that investment be like after 5 years. I'm going to change this to a B so I know it's a B. Okay, so plugging that into my calculator, 1 plus point, make sure you're using that extra set of parentheses. And it looks like we get 6,864.1, and it's a 0.6, so I'm going to round it to a 1.1. So comparing these two, investment A after 5 years went from $4,000 to $5,375. Investment B after 5 years went from $6,000 to $6,864. So after 5 years, even though investment B technically has the higher number, investment A started smaller and made a much bigger amount over that 5 years. So I would say that investment A is the winner. It makes you more money over time. Okay, let's look at another example. Okay, I want you to change a couple of things on this just to switch it up. I want you to switch this to monthly, and I want you to switch this one to daily. And again, if you're looking at investment A and investment B in this one, they're at different times, 6 years and 3 years. And we just talked about, in order to really make these comparable, we need to know what they're both looking like at the same amount of time. So let's change this investment B to 6 years and see what happens when they're both at 6 years. So let's look at investment A first. Investment A, it says it's starting with $3,000. And it has a percentage rate of 8%. So I'm going to switch that to a decimal, so 0.08. And we said that it was compounding monthly. Monthly is 12 times per year because there's 12 months in a year. And then we said we're going to look at 6 years. So let's type this all into our calculator. And remember, we need that extra set of parentheses because we had a fraction in it. So let's type this into our calculator and see what we get. Okay, so it looks like we get 4,840, and it was a 506, so I'm going to round it to a 51 because we're talking about money. I want 2 decimals. Okay, my next one, investment B, says it's starting out with $4,000. And its percentage rate is 3.6. So I'm going to move that decimal over to make it 0.036. It said we were compounding daily, which means we are doing this 365 days a year. So that is going to go on our denominator and in our exponent. And we are doing this for 6 years. So please type this into your calculator and remember that extra set of parentheses, please. So when we type this all in, it looks like we have 4,964.3 and it goes 566. So I'm going to round it to a 36 cents. So comparing these two, it looks like B has the higher amount, but A started $1,000 lower than investment B did. So it looks like investment A gained about $1,840 when investment B only gained $964. So again, it looks like investment A is our winner and has made the most money over time. Okay, something we've done before in the past, I want to touch on it one more time, and especially talking about it with a table. So looking for patterns again. How are we getting from 64 to 16 to 4 to 1? It looks like we are dividing by 4. Now, if you remember, in the last section, we talked about this being called your multiplier, which again, we have to say as your multiplier, what it's multiplying by. We said that this was dividing by 4. So we need to switch it to multiplying, and that would be multiplying by 1/4. So a 1/4. So switch that around for me, and let's put it into our multiplier section. And then we need to talk about your initial amount. Normally, it was always the very first number. When you're looking for an initial amount in a table, it needs to be when your x equals 0. So in this table, x equals 0 when y is 64. So that 64 was our initial amount. A lot of times on your homework, they might put that 064 somewhere in the middle of the table somewhere else to try to confuse you. Make sure you're always looking for when that 0 is in the x spot. So our equation would be 64 times a 1/4 to the x power.